Hi, and welcome to this physics tutorial. We're going to solve the problem shown. It says what happens to the volume of 1 liter of an ideal gas when the temperature is tripled while the pressure is held fixed. So it tells us that this is an ideal gas. So we're going to use the ideal gas law, where we have pressure, volume, number of moles, the gas constant, and temperature. Now we also have a different initial than our final state. So what I often do in these ideal gas law problems is I list out what I know for both my initial and my final states. So it tells me that my initial volume is 1 liter, and my final volume is what I'm trying to find. That's what they're asking us about. It also tells me that my temperature is tripled. Now, I don't know what the exact numbers for the temperature are, but I do know that they're tripled. So as long as my final temperature is triple what my initial temperature was, the problem will work. So it won't make any difference if you pick 10 Kelvin and then 30 Kelvin or 100 Kelvin and then 300 Kelvin. Now, one side note here is for ideal gas law, temperature must always be in Kelvin. And it needs to be in Kelvin in order for the problem to work. So you need to convert from Celsius to Kelvin if you're going to be using the ideal gas law. And then the last piece of information they tell me is that pressure is held fixed. That's the same thing as them saying pressure is constant throughout the whole problem. So now we've got our initial and final states written down. So after that, I'm going to use my ideal gas law, the PV equals nRT. And what I'm going to do is underline what stays constant and then move things around. So I know that my pressure stays constant. We know that from the problem. The number of moles will stay constant, and the gas constant will stay constant. So now I'm going to move everything that changes to one side and everything that stays constant to the other. So V over T both change, volume and temperature, but the gas constant, the moles, and the pressure all remain constant. So I'm going to move all of those things that stay constant to one side and everything that changes to the other side. And that becomes really important because now I can say that my initial volume divided by my initial temperature is equal to a constant that's also going to be equal to my final volume divided by my final temperature. So I can essentially simplify this equation to VI over TI, the initial states, to VF over TF are the final states. And then I plug in my numbers and solve for my final volume. So I have 1 liter as my initial volume, I have 100 Kelvin as my initial temperature, the final volume was what I'm looking for, and then 300 Kelvin is my final temperature. When I do the math and solve for the final volume, I get an answer of 3 liters. Not too bad. So see if you can find a problem similar to this so you can practice some of these same strategies. And just remember these when you're solving ideal gas problems. Good luck!